welcome to True Projects. In this video, we are going to explain the project protecting data privacy for permission blockchains using identity-based encryption. Introduction. This project's main goal is to enhance data privacy in permission blockchains. We want to do this while ensuring that authorized users can securely share data, all while keeping the data intact and secure. Traditional centralized systems and reliance on external verification methods such as SMS or email present serious security vulnerabilities and privacy concerns. These conventional approaches have become increasingly inadequate to meet the heightened demands of modern data privacy. To address these privacy concerns effectively, we propose the incorporation of identity-based encryption, that is IBE, into permission blockchains. IBE simplifies key management for users and guarantees secure data sharing. It also provides administrators with precise control over data access, enabling them to specify who can access particular data. And blockchain is like a digital ledger that records transactions securely and transparently. Instead of having all the data in one place, blockchain stores records as blocks of data, each with a unique code called a hash. These blocks are distributed across multiple computers or nodes, making it much harder for anyone to tamper with the data or compromise the entire system. Blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one vulnerable location. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes go down, others continue to maintain the data. And we have chosen to utilize the Ethereum blockchain. Ethereum stands out for its smart contract capabilities, which enable secure, transparent, and programmable data storage and management. Objective of the project. So, as I mentioned earlier, the project's primary objective is to develop a system that significantly boosts data privacy within permission blockchains. This means making sure that sensitive data remains confidential and inaccessible to unauthorized parties. Simultaneously, the project aims to enable secure and efficient data sharing among authorized users. This means that those who have permission can exchange information without compromising security. And we are dedicated to preserving data accuracy and preventing any unauthorized changes, even as data is shared and accessed. We use strong security measures like SHA-256 hashing to ensure data remains trustworthy. And the project aims to implement identity-based encryption, that is IBE. This cryptographic approach simplifies key management for users, making it easier for them to securely exchange data. It also offers administrators granular control over data access, allowing them to specify who can access what. The project aims to leverage the Ethereum blockchain, known for its transparency, immutability, and decentralized nature. This choice enables secure data storage and verification within a distributed network of computers. While blockchain is excellent for many data types, it has limitations with image storage. To address this, the project aims to integrate an IPFS, that is Interplanetary File System server, which excels at storing and retrieving images and other large files. And the project anticipates a growing number of users and increased data volumes, so scalability is a crucial consideration. The system is designed to handle this growth effectively and efficiently. Requirements needed to execute this project are hardware requirements: processor of i5 and above, RAM of 8GB and above, ROM of 25GB and above, and software requirements needed are Node.js, Python 3.7.0, and Visual Studio Community version. To execute this project, we have designed few modules. The first module is New User Sign-up. This module offers a secure and user-friendly way for individuals to create accounts within the application. Users provide their registration details such as a unique username, email address, and a password, which are carefully validated and stored on the blockchain, ensuring data integrity. Additionally, this module generates a specific identity-based encryption key pair for each user, enhancing the security of their interactions with the system. The second module is User Login. This module allows registered users to access their accounts securely. To log in, users need to provide their unique credentials, typically their username and password. These provided credentials are authenticated to ensure that only authorized users gain access to the application. The third module is Post Private Messages. This module empowers authenticated users to compose and share private messages securely. Users input the content of their messages and specify the intended recipients. Behind the scenes, the module generates encrypted messages using identity-based encryption, ensuring the confidentiality of the shared information. These encrypted messages, along with relevant data, are stored securely on the blockchain. The last module is View Shared Private Message. This module lets message owners and authorized users read shared private messages safely. It shows a list of shared messages and uses the recipient's private key to unlock the content. This ensures only authorized users can view and understand the messages, keeping the information private and confidential. Blockchain integration. So, Ethereum's blockchain serves as a secure repository for various types of data, including user sign-up information and private messages. Smart contracts on the Ethereum blockchain enforce predefined rules, improving security and transparency. They validate user actions, ensure data integrity, and enable secure sharing. And blockchain's decentralization removes the need for a central authority, boosting security. Data isn't vulnerable to a single point of failure, reducing risks and ensuring data resilience. And data integrity is maintained in the system through the utilization of the SHA-256 algorithm, that is secure hash algorithm 256-bit. Each block in a blockchain is linked with a unique hash code. These blocks are maintained across multiple nodes or servers. Before storing new records, blockchain verifies the hash code of each block. If any block data is modified, it results in a different hash code, triggering security alarms and ensuring the integrity and immutability of the data. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is data privacy folder. Inside this folder are Python code files that are intended to be dynamically loaded into the project during runtime. This is data privacy app folder. This folder comprises a static folder which contains files related to CSS, JavaScript and Bootstrap. These files contribute to the visual and interactive aspects of the application. And data privacy app folder also contains a templates folder. Within this folder, we'll find all the HTML pages used throughout the project. It includes pages like index.html, home.html and more, representing various sections of the website. And it also contains Python code files that will be executed during the runtime of the application, supporting its functionality. And this is Hello ETH folder. In this folder, I have a node modules folder. This folder consists of dependencies or modules needed for the project. Now open .bin folder. This folder often contains executable scripts related to the project's dependencies. So here we can see a run blockchain.bat file. Double click on it to start the blockchain. So this script will initiate the local Ethereum blockchain for development purposes. It contains commands to start the blockchain environment. Now the blockchain is hosted on the local machine at the local host and port. This address allows us to interact with the blockchain using various tools and applications. Now execute the command truffle space migrate to compile and deploy the smart contracts. I'm typing truffle space migrate and hit the enter button. So Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. They are deployed on a blockchain network and can facilitate various transactions such as transferring tokens or managing digital assets. Once the migration process is complete, Truffle will provide us with a unique Ethereum contract address. So this is the contract address. This address represents the location of the deployed smart contract on the blockchain. And here we can see gas used. To execute the Solidity file and compile smart contracts, this is the amount of gas consumed. Now minimize this. This is data privacy SQL file. This file consists of Solidity code. It handles data structures, functions and events with modifiers for validation. This is manage.py file. It is a command line utility that comes with Django. It provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations, and more. This is start ipfs.bat file. This bat file is used to start IPFS server, which is used to store all product images, as blockchain itself cannot store images. Now double click on it to start IPFS server. So the IPFS server has been started. Now minimize this. This is run server.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Now double click on it to start the Django application. So the Django framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I am copying it and paste it into any web browser. I prefer Chrome. After pasting it, type index.html at the end and hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Django framework. And here we can see user login and new user sign up links. If we are new users, we have to register first. Click on new user sign up link. Now fill in all these details. The username would be Ram. Give the password. Give the contact number. Select the gender. Give the email ID. Give the address and click on submit button. So in the red color text we can see sign up process completed and record saved in blockchain. We will create another 2 accounts. The username would be Ravi. Give the password. Give the contact number. Select the gender. Give the email ID. Give the address and click on submit. So the record has been saved to blockchain. We will create another account. The username would be Raju. Give the password. Give the contact number. Select the gender. Give the email ID. Give the address and click on submit button. So the sign up details have been saved to blockchain. Now we'll log in. Click on user login link. First we'll log in as Ram. Give the credentials, username and password of Ram. And click on login. So we have logged in as Ram and here we can see post private messages, view shared private messages and logout links. Click on post private messages link. So here we can post a message. The post tweet would be computer vision. We can upload the image here. Click on choose file button. So I'm selecting this image and click on open. Now we will select list of users to share the message with and we can select multiple users by holding Control key. But I'm selecting only one user. To view the message, I am giving it as Raju to view the message and now click on submit button. So we can see the message has been posted and it is saved in the blockchain and we can see the hash code of the message. And media file is saved to IPFS and the hash code generated by IPFS will be saved to blockchain and we can also see IBE encrypted message. Now click on view shared private message link. So here we can see the posted message, the tweet owner name, posted message, the shared users list, message blockchain hash code, the image and the message date and time. Now click on logout. Now we log in as Raju. Click on user login link. Give the credentials, username and password of Raju. And click on login. So we have logged in as Raju and now click on view shared private messages link. So here Raju can view the shared message because he was given the access to view the message. Now click on logout. Now we log in as Ravi. Click on user login link. Give the credentials of Ravi. And click on login. So we have logged in as Ravi. Now click on view shared private messages link. So here we can see there are no messages shared to Ravi because we haven't given the access to view the message. Now click on logout. So the conclusion here is the project has successfully bolstered data privacy within permission blockchains. It addresses security concerns linked to traditional methods, ensuring that sensitive information remains confidential. Users can now share data securely and efficiently while ensuring that the data's integrity remains intact. This is made possible through the integration of identity-based encryption and blockchain technology. IBE simplifies the process of encrypting and sharing data, enhancing security. By utilizing the Ethereum blockchain, the project has established a strong and decentralized foundation for data storage. This ensures that data is transparently recorded and cannot be tampered with, providing trust and reliability. The IBE system allows for precise control over who can access shared data. Only authorized users possess the keys necessary to decrypt and view the information, ensuring that sensitive data remains protected. And the project introduces a novel approach to data sharing that does not rely on traditional transaction methods. This eliminates the need for external verification methods like SMS or email, simplifying the sharing process. The integration with IPFS expands the project's capabilities by enabling secure storage of various types of data, including images. And the project's design ensures that it can adapt and grow seamlessly. It can accommodate an increasing number of users and larger data volumes while maintaining optimal performance and security standards.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.